Hello everyone, welcome to this session. Our chapter is animators and their compounds. So far in our previous video, we discussed about the chlorine, also its existence, its various properties, talking about the physical and the chemical properties. We also saw how we can prepare the chlorine and also the various uses of the chlorine in our daily life. So today, let's move on to the other non-metal, that is the hydrogen chloride. So we'll start with the introduction to this hydrogen chloride. The hydrogen chloride, this is the gaseous compound at room temperature. So that's how it exists. This hydrogen chloride, it exists as a gaseous compound at this room temperature. It is usually prepared in the laboratory by the preparation between the concentrated sulfuric acid and any chloride, for example, the sodium chloride. And when the mix of these two is gained to warm, the hydrogen chloride gas is formed. And here is how it occurs. So this is the illustration of how the preparation of the hydrogen chloride takes place. The reaction between the concentrated sulfuric acid plus the sodium chloride and heating is just the sodium hydrogen sulfate plus the this hydrogen chloride. So that's how you can prepare the hydrogen chloride in the laboratory. The properties of the hydrogen chloride gas. We start with the physical properties of the hydrogen chloride gas. The first one is that it is a colorless gas with a choking, irritating smell and an acid taste. So this is the first property of the physical property of the hydrogen chloride gas. It is simply a colorless gas, meaning that it has no color. This kind of a gas with these features: the choking, irritating smell and an acid taste. The other is that it is heavier, yes, or yes, denser gas than air, and also it fumes in the most moist, in most area. I mean, in most air, due to the formation of the tiny droplets of the hydrochloric acid. Also, it is very soluble in water, talking about 450 centimeter cubes of gas in just 1 centimeter cube of water. The acidic properties and the solubility of the hydrogen chloride gas can be best shown by the fountain experiment. So you can get that, getting to know these acidic and the solubility properties of this hydrogen chloride gas. Moving on, let's see the chemical properties of this hydrogen chloride gas. The first one is that a dry sample of the hydrogen chloride gas simply has no effect on dry blue litmus paper, but it has an effect in a way that it turns the moist blue litmus paper to lead. So this is the first chemical property of this hydrogen chloride gas. It turns the moist blue litmus paper to lead. This is due to the acidic properties of the hydrogen chloride gas. So due to the acidic properties of this hydrogen chloride gas, it has an effect on moist blue litmus paper, turning it to lead litmus paper. The other one that it does not burn and it does not support combustion. So this is the other chemical property of this hydrogen chloride gas. It doesn't support combustion since it does not burn. The other one that when a stream of this hydrogen chloride gas is passed over some heated metals, the hydrous chloride of these metals are formed. So a stream of this hydrogen chloride gas, when it is just passed over some these of the heated metals, the hydrous chloride of these kinds of metals, these heated metals are formed. And here are the reactions how they occur. Moving on, it is decomposed by strong oxidizing agents such as the manganese dioxide, the lead dioxide, and the lead lead, just to give the chlorine gas. And here are the reactions how they occur. So they decomposed by strong oxidizing agents. We've seen these strong oxidizing agents in these reactions, the manganese dioxide and the lead oxide, just to provide the chlorine gas and the lead lead. So that's the chemical property or the decomposing property of this hydrogen chloride gas with these strong oxidizing agents, the manganese and the lead dioxide. Also, when the gas is passed through a solution of silver nitrate acidified with the dilute nitric acid, a white precipitate of silver chloride is formed. So that's the other property of this gas when it is passed through this solution of silver nitrate. acid provided with the dilute nitric acid. So the result is that a white precipitate of silver chloride is what is formed, and this is just another way on how you can test for this I mean you can test for the presence of this hydrogen chloride gas and just all other soluble chlorides. And as you can see the reaction, how it occurs, leading to these white precipitates. Uh, so that's how you can see concerning this property of this hydrogen chloride gas. The other one is that it gives clouds of white fumes when brought into contact with the ammonia vapor. So that's the other chemical property of this hydrogen chloride gas. It gives kinds of these clouds of white fumes when it is brought with the contact with this ammonia vapor. The fumes are just solid ammonium chloride. And here's how the reaction how it occurs. Now, in qualitative analysis, this is just the chemical test for the hydrogen chloride gas as well as the ammonia gas. The reaction which you've seen is just the test in qualitative analysis. This is just kind of a chemical test for this hydrogen chloride gas as well as the ammonia gas. Now, let's see this chemical property, the reactions of the aqueous hydrogen chlorides. The hydrogen chloride gas is very soluble in water and in other polar solvents. In water, an acid solution is formed, which is the hydrochloric acid. So when you react the hydrogen chloride gas with this water, an acid solution is formed, which is simply the hydrochloric acid. In aqueous solution, the hydrogen chloride molecules they dissociate into hydrogen ions and the chlorine ions. As you can see, how the dissociation how it occurs. The solution is what we call the hydrochloric acid. The hydrochloric acid it is simply reacts with metals, metal oxides, hydroxides, the soluble bases, and the metal carbonates, and you can see how it reacts. Moving on, this suggests that when the hydrogen chloride gas is dissolved in water, an acid solution is formed. For example, it turns the dark blue litmus paper red. It reacts with various substances like other acids. As you can see, there's a table which you see below next slides, and also it conducts electricity using the hydrogen gas at cathode and the chlorine gas at the anode. And here is the table reactions of the aqueous hydrogen chlorides. The acid reacting with, you can see here, and the general equation how it occurs. So the first one that action of the acid reacting with the oxide, talking about the base oxide. So the general equation is like this: acid plus the metal oxide is equals to the salt plus water. So basically it is equals to the neutralization reaction. So that's how it is. Also, the other one is that reacting of this aqueous hydrogen chloride reacting acid, this kind of acid reacting with alkali, that is the soluble base. So the general equation is that acid plus metal hydroxide, that is the alkali, is equals to the salt plus water, and also acid when it reacts with the metal is to the general equation as it is. Acid plus metal resulting to the salt plus the hydrogen, and also the acid when reacting with the metal carbonate. The general equation becomes acid plus metal carbonate is equals to the salt plus water plus carbon dioxide gas. So that's all I have for this session. We've seen the hydrogen chloride. We've seen how it can be prepared in the laboratories. We've seen the restoration of it, and we've seen the various properties of this hydrogen chloride gas, the chemical and the physical properties. So I hope that's all clear for this session. So in the next session, we'll see the various uses of this hydrogen chloride gas. So I hope that's all clear, and thank you.